The universe is filled with billions of galaxies, trillions of stars, and countless mysteries. Yet the most extraordinary discovery in human history may still be waiting for us. And when we finally find it, nothing we believe about the universe will ever be the same again. For decades, NASA has transformed impossible dreams into reality, from landing humans on the moon to sending robots across Mars and launching the James Webb Space Telescope, which revealed galaxies formed just a few 100 million years after the Big Bang. But NASA believes these achievements are only the beginning. Right now, several future missions are being developed that could rewrite the history of space science forever. These missions are designed not just to explore new worlds, but to answer humanity's biggest questions. Are we alone? How did life begin? What is the universe made of? And could humans someday live beyond Earth? Unlike previous missions that focused on a single destination, NASA's future plans combined advanced artificial intelligence, next-generation spacecraft, powerful telescopes, and revolutionary technology to explore places humanity has never reached before. Scientists believe within the next 2 decades, these missions may lead to discoveries more important than the Apollo moon landing or even the Hubble Space Telescope. One of NASA's most exciting projects is the Nancy Grace Roman Space Telescope, often called the next great observatory after Hubble and James Webb. While Webb studies small regions of space in incredible detail, the Roman telescope will survey enormous areas of the universe nearly 100 times faster. This mission is expected to discover thousands of new exoplanets, including Earth-sized worlds that may orbit inside the habitable zones of distant stars. Even more importantly, Roman will investigate one of the greatest mysteries in physics: dark energy. Scientists estimate that nearly 70% of the universe is made of this mysterious force, yet nobody truly understands what it is. By mapping billions of galaxies and measuring how the universe expands over time, Roman may reveal whether our understanding of gravity is incomplete, or whether entirely new laws of physics exist. If successful, it could fundamentally change cosmology in the same way Einstein changed physics over a century ago. Another mission that could redefine science is a Dragonfly mission to Titan, Saturn's largest moon. Unlike traditional rovers that crawl across the ground, Dragonfly is a nuclear-powered flying drone capable of traveling dozens of kilometers between scientific sites. Titan is unlike any other moon in our solar system. It has rivers, lakes, rain, clouds, mountains, and sand dunes, but instead of water, these features are made of liquid methane and ethane. Beneath Titan's icy crust may lie a massive underground ocean of liquid water. Scientists believe Titan closely resembles Earth before life appeared about 4 billion years ago. By analyzing the moon's complex organic chemistry, Dragonfly may discover the ingredients that led to life on Earth. If similar chemical reactions are found there, it would suggest that the building blocks of life may naturally form throughout the universe, dramatically increasing the possibility that life exists elsewhere. NASA is also preparing one of the boldest missions ever attempted, the Mars Sample Return Program. Previous rovers, such as Perseverance, have already collected carefully selected rock samples from an ancient Martian river delta believed to have once supported flowing water. Instead of analyzing every sample on Mars, NASA plans to bring these priceless rocks back to Earth using an incredibly complex multi-spacecraft mission involving landers, rockets, orbiters, and autonomous robotics. Once these samples arrive in Earth's laboratories, scientists will use instruments far more powerful than anything that can be sent into space. They will search for ancient microbial fossils, chemical biosignatures, preserved organic molecules, and evidence of past habitability. If even microscopic proof of ancient life is discovered inside these rocks, it would become one of the most important scientific discoveries in human history, proving that life evolved independently on 2 different worlds. Beyond Mars, NASA is looking toward one of the most fascinating moons in the solar system, Europa. Beneath Europa's thick shell of ice lies an enormous global ocean containing more water than all of Earth's oceans combined. NASA's Europa Clipper mission is designed to perform dozens of close flybys using radar, infrared cameras, magnetic field measurements, and high-resolution imaging to study the moon in unprecedented detail. Scientists hope to locate regions where underground water rises close to the surface or escapes into space through giant water plumes. If Europa possesses liquid water, chemical nutrients, and internal heat, it may satisfy the three essential ingredients believed necessary for life. Discovering even simple microbial organisms beneath Europa's frozen surface would completely transform biology, astronomy, and humanity's understanding of life itself. NASA is also investing heavily in the future of human space exploration through the Artemis program. Unlike the Apollo missions, which briefly visited the moon, Artemis aims to establish a long-term human presence. Astronauts will build lunar habitats, test advanced life support systems, mine local resources such as water ice, and prepare technologies for future missions to Mars. The planned Lunar Gateway, a small space station orbiting the moon, will serve as a transportation hub for deep space exploration. By learning how humans survive for months or even years outside Earth's protective environment, NASA hopes to make interplanetary travel practical. The moon is no longer viewed as the final destination. It is becoming humanity's training ground for exploring the solar system. While these missions focus on nearby worlds, NASA is also planning revolutionary observatories that could directly search for signs of life around distant stars. Future concepts such as the Habitable Worlds Observatory are being designed to detect tiny atmospheric gases like oxygen, methane, carbon dioxide, and even possible biosignatures on Earth-like exoplanets. Previous telescopes could only estimate whether planets existed, but these future instruments may actually analyze their atmospheres in remarkable detail. Imagine the moment when astronomers discover a distant planet with an atmosphere nearly identical to Earth's, showing strong evidence of biological activity. Such a discovery would answer one of humanity's oldest questions and forever change our place in the universe. Another revolutionary direction is NASA's growing use of artificial intelligence and autonomous robotics. Future spacecraft will increasingly make decisions without waiting for commands from Earth, which can take minutes or even hours to arrive. Intelligent systems will identify scientifically important discoveries, avoid hazards, optimize energy use, and even repair equipment independently. Swarms of small robotic explorers may one day map asteroid fields, investigate underground caves on Mars, or explore the icy oceans beneath distant moons. Compared to earlier missions that relied heavily on human control, these next-generation explorers will operate almost like independent scientists traveling through space. Perhaps the most exciting aspect of NASA's future is that no one knows which mission will produce the next world-changing discovery. History has repeatedly shown that the greatest breakthroughs often come from unexpected observations. Hubble unexpectedly revealed that the universe's expansion is accelerating. The Kepler mission discovered that planets are common throughout the galaxy. James Webb uncovered surprisingly mature galaxies from the early universe that challenged existing theories of cosmic evolution. NASA's upcoming missions may once again force scientists to rewrite textbooks, challenge long-held assumptions, and develop entirely new scientific theories. Whether the discovery is ancient life on Mars, living microbes beneath Europa's ice, evidence of habitable worlds around distant stars, or a completely new understanding of dark energy, the next great revolution in science may already be on its way. As humanity enters this new era of exploration, NASA's future missions represent far more than technological achievements. They symbolize our endless curiosity, our determination to answer impossible questions, and our willingness to venture beyond the known. Every spacecraft launched, every image transmitted, and every sample collected brings us one step closer to understanding who we are and where we belong in this vast universe. The discoveries waiting ahead may not simply expand our knowledge, they may completely rewrite the story of space science forever.